Hello everyone, I am Tapan Hajra, student of IIT-JEE. So in the previous video, I was discussing about differentiation and continuity. In this video, I am going to discuss integration. So what do you mean by integration? So integration is just a reverse process of differentiation. In differentiation, we were usually separating things. For example, we considered in that there was a road. For example, I am having a road whose length is L. So in differentiation, what actually we usually do? I just divide as small as possible. So I used to divide as small as possible this road. Then I find a small length. I was choosing a small length. So whose length is very small. Whose length is very small. L is the capital L is the dimension of the road, and I divide infinite times to get a smaller one whose length is very small. So this was principle behind differentiation. So in integration, I will join. I will just join. I will join. For example, this has a length dx. This again has a length dx, and all the pieces has length dx. So in integration, I will join all those small. I will join those small parts to make this bigger rod of length L. So how can I mathematically show this? So I mathematically write as this f of x. So integration of this. So for example, I have this. I write f is equal to integration of this. So we usually integrate this. This function can be anything as we did before for differentiation. So let's see the formula, important formulas. So let me write. I am dividing this board into two sections. Here will be differentiation formula. This was a differentiation formula, and here will be integration formula. So physically integration, you can understand that. For example, I have a container. And this container is empty. So if you place this container outside when it is raining, then it was initially empty. After some time, maybe few hours, you will see that this container will be filled with water. How this water comes? So this water come into this container in the form of drops. So these drops join together to form bigger one. So you will find that after few time or few minute or few hour, you will find that this container is filled with water. So what was the process? The process was just a combination of these water drops. Large number of water drops joined together to form bigger size of water. So similarly, so this was the process, reverse process of differentiation. So the formula in the differentiation, I wrote that first formula was differentiation of x to the power n. So differentiation of x to the power n was n times x to the power n. So in integration I will write just opposite. The integration of n times x to the power n dx will be, write this one x to the power n, or I can write this one as integration of x to the power n dx. This was n minus 1, sorry, this was n minus 1. So x to the power n integration of x to the power n minus 1 dx. I am just putting this one onto right side. So this will be x to the power n divided by n. So just see, integration is just reverse order of differentiation. So next formula was derivative of ln x natural logarithm. So we discussed the derivative of natural logarithm was 1 by x, and here will be just opposite. So it will be just integration of. So integration of this one is this one. So integration of this one is ln x. So third is, for example, I am putting nothing here if my function is 0. So derivative of 0. Or for example, the derivative of I am constant. There is a constant instead of any variable. There is a constant c. Then it will give rise to this will give rise to 0. Okay. What will be here? Just opposite. So just write integration of 0 will give rise to constant c. So let's see other formulas. The next formulas are next formula, exponential formula was so this would be a differentiation of a to the power x. So differentiation of a to the power x is a to the power x ln a. So this was our formula. Just put it inverse. So here integration of a to the power x ln a dx will be a to the power x. Or I can simply put this in. This is a constant. I can take outside of this integral, then divide by this one. So it will be a to the power x dx is equal to a to the power x by ln a. ln. And for simplicity, I can put a constant here. So in every formula, when we usually integrate, there will be a constant on the right side, because integration, we have seen that integration of 0 is constant. That is why I am putting constant on the right side of this integration. So every formula, everywhere I will put constant here. So no problem, I find. So next formula is trigonometric functions. So next formulas are trigonometric functions. So first formula was this would be sine. The first trigonometric function is sine. So just I discussed already this formula, that derivative of sin x is cos x. So I will just write cos x here. Then in integration it will be just reverse, so just write integration of cos x dx will be this one, so it will be sin x plus c. You have to always put plus c here on the right side. Next formula was dy dx of cos x is minus sin x, and just put it just use this reverse formula. Okay, so minus sin x dx will be, what will be this, cos x, and a constant on the right side. So there are other formulas, you can collect those formula from your books. So next move to the geometrical interpretation. So how geometrically we interpret these differentiation or limits or integration formulas. So let us define our differentiation. What differentiation says about when how can I represent differentiation geometrically? So for example, I'm considering this is my y-axis and this is my x-axis. So this is my y-axis, this is my x-axis. So if there is a graph, I am having a graph, this graph. So if I want to find, for example, this graph, equation of graph is y equal to f of x. So I am considering a graph whose equation is equation of trajectory. We call this as a equation of trajectory. So I am having a graph. So I want to find slope of this graph. So how can I find the slope of the graph? So, at a certain point. For example, I am considering this is a point whose coordinates are x and y. For example, I am considering a point P. Whose coordinates are x and y on this graph, on this curve, whose equation is y is equal to f of x. So if I want to find slope of this graph at this point, so how can I plot? I will just take a small element of this graph. I will just take a small element of this graph. Then I will draw two lines. I will draw two lines. One line parallel to y-axis and another line parallel to x-axis. Then this angle, so I considered this line. So here we had a point. So for example, the width of this line is dx and dy, and the horizontal one is dx. Dx means I am considering very small. I am considering a small part of this. So you can take this is a very small, and you can consider also for dy also very small. Then the angle, this angle, if I take tan theta, so tan theta from the formula tan theta is defined as this one, this angle. So this is dy by dx, this one. So this one is divided by this one. So geometrically what this says? this is our derivative. This is our derivative. So derivative, our derivative just says that the derivative of a function is just is nothing but a slope of a curve. If I want to find a slope at a certain point, I will just take derivative of that function with respect to an independent variable. Then I will put the value of that function. I mean, for example, there is a curve. Let us discuss a curve. Yeah. For example, I want to draw this curve. So this is a parabola. I already discussed how parabola look like. So parabola will be this like. Parabola will be like this. So if I want to, this is my y-axis and this is my x-axis. So consider a point. For example, in the question, it is given that find the slope of the point. For example, this is a point P whose coordinate is 1 and 2. So I am considering a point whose coordinate is 1 and 2. 1 means 1 is the value of x and 2 is value of y. So if I want to find the slope of this curve at a point P, then how can I find? I will just take derivative of y with respect to x, then I put the value of x and y at the derivative. So what is this? So y is equal to x square. So derivative of y with respect to x will be simply 2x. Will be simply 2x. So what is the slope? So slope will be dy by dx at x is equal to what? At x is equal to 1. So x is equal to 1. So at x is equal to 1, what is this? X is equal to 1. So 2 multiplied by 1, because a value of x is 1. So 2 into 1 will be 2. So what is the slope of the curve at point P? So at point P, the slope of the curve is 2. So this was the geometrical interpretation of derivative. So let us discuss geometrical interpretation of integration. How integration physically mean or geometrically mean. So for example, there is a curve. We have a curve. This is y. Now this is x-axis, and this is our y-axis. Then I have a curve like this. I have a curve like this. I am considering this is a y is equal to f of x. This is y is equal to f of x. Then I want to consider how much area is within this curve. So if I take this small element of this one, so if I want to take this small element, this small element is dx. This small element is dx, and this one is, for example, y. This one is y. Then if I want to find area under this curve, then I will divide this curve. I mean, we had a curve which looked like this, and I had taken a small element of this one, and whose length was dx, and height was y. I mean, height will be up to this. Then if I want to find the area under this curve, then I will divide this curve. I will divide this curve infinitesimally. Then I will take an element dx. Then I will integrate. I will integrate means I will also have here. Then all the elements I will join together. Then it will look like this. Why? I mean, I can replace this one as a summation. Sum. I will just integrate this curve. For example, this one is a A1, this one is a A2, this one is a A3, this one is a A4, this one is a A5, like this. So I will just join all the areas. I mean, it will be just A1 plus A2 plus A3 plus dot. So A is what? A1 is area of this line, area of this the curve under this. So area is area of this region. A2 is area of this region. For example, A4. So A4 is area of this region. This is the area of this region. Then if I want to find the area under this curve, then I will have to join all the elements below this curve from here to here. So for example, this is a x is equal to a, and this point is x is equal to this is x is equal to b. Then if I want to find the area under curve which extends from x is equal to a to x is equal to b, then I will just join all the area element A1, A2, A3 like this, all the elements. So there will be infinite elements A1, A2, A3 up to infinity. Then I have to write in this way that A1, A2, A3 plus A4 plus up to plus an plus up to infinity. So there will be infinite elements, infinite sections. Then I will just replace summation of ai. So this is written as for example, this is written as integration. I just replace this summation as integral. And what was our area? Our area was this was the element previously. This was our element whose length was dx, and height was y. Previously we discussed. Previously I had taken that the element which was looking like this, whose height was y and width was dx. So if I consider this is as a rectangle, then what will be the area of a rectangle? So area of a rectangle is multiplication of length multiplied by width. So length is what? Length is our y and width is dx. So area is our y dx. So this sign, this integral sign is represent this sum. This integral represent this sum and area is this one. So this is how integration is represented. So in this video I discussed how and what is the geometrical interpretation of differentiation and integration, and what was integration concepts was derived. I discussed. So See you in the next class. Thank you.